Good morning. Today we will start with a new topic that is known as friction. Before proceeding towards the numerical side, let us first start to understand what do you mean by a free body diagram. This is the most important point in this particular topic, as if you make this free body diagram wrong, the entire numerical will become wrong and you will get 0 marks. So let us first try to understand what do you mean by free body diagram and how to draw free body diagram. What are the forces to be shown under the free body diagram? The first thing is what do you mean by a free body diagram? So basically, free body diagram is when you draw a body relieving or removing all the supports from which it is supported. For example, let us say this in this figure number 1, this particular ladder is being supported at this particular point B and this particular point A. So now if I remove these supports and draw the diagram, that will be known as the free body diagram of that ladder. So let us start with drawing the free body diagram. So first I will remove all the supports and draw the ladder like this. So this is a ladder which is at point starting at A and going up to B. Now, how to draw the free body diagram, or you can say what are the forces to be considered while drawing free body diagram. So the first force which we consider while drawing the free body diagram is the applied force. The force which is shown or which is applied on the body. So if I observe this figure carefully, there is no applied force which is applied on this particular body. So we will not make any applied force. Second force which we are going to show in the free body diagram is the self weight. Self weight, just remember that self weight to be shown always vertically downwards and at the center. So if I take the center of this rod AB or this ladder AB, center will be somewhere here and the weight will be shown perfectly in vertical direction. So this is your weight W. So first force was applied force. As there is no applied force in the body, it is not shown. Second is self weight, which is shown as W vertically downwards at the center. Third thing which we are going to show is reaction from contact surfaces. Now, regarding contact surfaces, the number of reactions will be equal to number of contacts. And second thing which you have to remember is reactions will be always perpendicular to the surface and the direction to be shown from the surface towards the body. I repeat again, for the reaction from the surfaces, the reaction to be shown from the surface to the body, the direction part, and it will be perpendicular to the surface. Now, if I observe the figure or diagram AB again, there is a support at this particular point A. So now here the support or the surface is horizontal. So my reaction will be vertical. It should be perpendicular to the surface. So I will make one perpendicular line at A. So this is your reaction. Now regarding the direction it is like, it should be from the surface to the body. It should be directed from the surface to the body. So I will make this force like this. And let us say, is it a normal reaction? So I will write it as N1, reaction from the surface. Another support here, it is at this particular point. Now here you can observe that the surface is vertical. Now because surface is vertical, reaction will be horizontal, that is perpendicular to the surface, and the direction will be from the surface to the body. So the direction will be like this. So I will make the same thing here at particular point B and I will name it as, let us say, N2. So we have completed the third part wherein we have shown reactions at contact surfaces. Now the last part. Last force which we are going to show in the free body diagram is the friction force. And for friction force, you have to remember, like, friction force is a force which opposes the motion of the body. So it should be shown in the direction opposite to the motion of the body. Now again, if you refer the diagram given in the question for the ladder, this ladder will try to slip. This point A will move towards this side towards left and point B will move towards downside. So this is the direction of motions for point A and B. Friction force will be opposite to these directions. So if I make the friction force at point A, the motion is towards left, so the friction force will be towards right side. So I make one force which is on the right side, and I will name it as mu multiplied by N. That is friction force at this particular point. Similarly, at point B, the motion of point B is towards downside. So the friction force acting at point B will be towards upside, and the value will be coefficient of friction, that is mu multiplied by N2, the normal reaction at that particular point. So this completes the free body diagram of a ladder supported at points A and B. Now, let us go to the second case, wherein there is a block of weight W again kept at the floor. So if I make the free body diagram, as I said, what is free body diagram? Free body diagram is when we remove all the supports of the body and draw the diagram and show all the forces acting on the body, that is known as free body diagram. So first of all, I will isolate the diagram. So this is my body W, which I have isolated. The first thing to be shown in the free body diagram is the applied force. So here in the given question, you can see that there is a force P which is applied at an angle of 45. So I will show the applied force as it is. So this is force P acting at some angle theta, that is 40. So I have completed my first part, that is show the applied forces. Second part we show is, or the second force which we show in the free body diagram is the self weight. Self weight, as we have discussed, it will be vertically downwards at the center. So I will make one force here in vertically downward direction, and I will name it as W because the weight given is W. So second part is also done. Third part. For third part, it is reaction from contact surfaces. Now in the diagram, you can see that this particular body of weight W is in contact with this particular surface. Now, as the surface is horizontal, the reaction will be vertical. And the direction will be from the surface towards the body. So it will be like this. So I will make this in the free body diagram like this. A force or the reactive force, and I will name it as, let us say, N1. Now the last force to be shown in the free body diagram is the frictional force, and as discussed, it will be the force opposing the motion of the body or opposite to the motion of the body. Again, if you look at the diagram given, because of this load applied P, this body will try to move in this right direction. Now, because the body is moving towards right side, friction force will come towards left side. So I will make one force on the left side, and I will name this as mu multiplied by N1, that is friction force. So this completes the free body diagram of a block kept on a surface. Now let us go to the third case, wherein we have the cylinder of weight W again resting on the surface. So again, for a free body diagram, I will isolate the body from all the contact surfaces. So let us say this is a body which has been isolated, a circle or a disc. The first force which we show on a free body diagram is applied force. So here, if you observe in this particular diagram, there is no applied force given, so we don't need to show any applied forces. Second is the self weight. Self weight to be shown vertically downwards with a weight W. So weight is W and shown vertically downwards. The third force which we show is the reaction due to contact surfaces. Now, this particular cylinder is in contact at this particular point in the diagram, at this particular surface. So now again, as the surface is horizontal, the reaction will be vertical. So I will make this kind of reaction, and the direction will be from the surface towards the body. That means the direction will be like this. So I will just transfer this into a free body diagram. that there will be a normal reaction from the surface, and that will be known as N1. Now the last force. Last force is the frictional force, which is in the direction opposite to the motion of the body. Now let us assume, as the direction of the motion is not given, let us assume that this is moving in the clockwise direction. So when this circle or the disc is moving in clockwise direction, this particular point which is in contact will move towards this side. This is moving towards this side. Now, because the point is moving towards this side, the friction force will be towards right hand side. So I will make a friction force towards right side here, and the value will be again mu multiplied by N. This completes the free body diagram of this particular case. Now, let us go to the next one. The fourth case, wherein there is a block of weight W acting or kept at an inclined plane which is acting at an angle of theta. So again, same procedure we will apply. I will isolate the body from all the contact surfaces. So it is like this, a body kept on an inclined surface. Then starting with the free body diagram, first thing which we have to show is the applied force. So I will show the applied force as it is shown in the diagram. So it is P. Then self weight to be shown vertically downwards. Whatever be the position of the body, self weight will always be shown vertically downwards. So I will make this as a vertically downward force of weight W. Then the third force which we show in the free body diagram is the reaction force. And we know that reaction force or the reaction from contact surface is always perpendicular to the surface. Now, if you observe the surface on which the body is kept, the surface is inclined like this. So the reaction perpendicular to it will be in this particular direction, the perpendicular direction. The reaction should be perpendicular and it should be from surface to the body. That means the direction will be like this. So I will just convert or transfer it into free body diagram. So I will get one force here and I will name it as, let us say, N1, reaction from contact surface. It is perpendicular to the surface. And the last one is the friction force. So as it can be seen from the diagram, because of this force applied P, this body will try to move up the plane. Hence, the friction force will be acting down the plane with a value of mu multiplied by. This completes the free body diagram of this particular case. Now let us go to the last case. Body under consideration here is the cylinder. So I will isolate the cylinder from the contact surfaces and all the contact points. So this is the cylinder which is isolated. The first thing which we have to show is the applied force. Now, if you observe this figure correctly, there is no applied force given as such. But this particular body, this entire body which is given in the diagram, is being supported by this particular cable, this cable. So cable will always give the tension force and it should be shown always away from the body. So that can be considered as the applied force and it should be shown away from the body. So I will make a force like this along the thread length. I will name it as tension in the string. Then next force which we are going to show in the free body diagram is the self weight, which we have discussed. It will be vertically downwards and the center. So from center, I will make a vertically downward force and name it as self weight. Then third is reaction from contact surfaces. Now, this particular body is in contact with the surface at this particular point. And the surface of contact is vertical, hence reaction will be horizontal. And the direction will be from the surface to the body, so it will be like this. So transferring the force here, I get this as the force and I will name it as, let us say, N1. Now, regarding the friction force, because this body is not moving with respect to any of the surface, there is no friction which will be coming into picture. So this completes the free body diagram of the object shown. So we have discussed 5 different cases in which we have drawn the free body diagram. I hope you have got the concept of drawing the free body diagram correctly. So just to summarize the things, the free body diagram is a diagram which is made by isolating the body from all the contact. Then to draw the free body diagram, first force which we are going to show is the applied force, or you can say a force in a cable or a string or a thread. That is considered to be its applied force, which has to be shown as shown in the diagram. In case of cable and rope, it should be shown away from the body as the tension. The second force which we are going to show in the free body diagram is self-weight. So let me write somewhere. Yeah. So the first force which we are going to show in the free body diagram is the applied force. The second force which we show is the self-weight. The third force which we show in the free body diagram is the reactions. And the fourth force which we show is the friction force. So when we complete showing all these forces acting on the body, and the diagram so formed will be known as free body diagram. So hope you have understood. So in the next class, we will start with solving of the problems. For today, we will stop the lecture here. Thank you.